And now the last video of the day is on the empirical rule. If we have a large collection of data that is normally distributed, that is, if you made a histogram, it would be one of those tall in the middle, skinny on the outsides, bell-shaped curve, then we have the 68, 95, 99.7 empirical rule. That is, 68% of the data is within one standard deviation of the mean, plus or minus a standard deviation, as we talked about in the last video. 95% of that data is within two standard deviations of the mean, up 2 standard deviations or down 2 standard deviations. And 99.7% of the data is within 3 standard deviations of the mean. These are very popular numbers in statistics. You will see 99.7% or 95% or 68% a lot of the time. Let's look at an example. Suppose there's some breed of dog, I don't know, and the average weight of one of these dogs is 80 pounds. The mean weight, you add up, took all the dogs of this breed in the entire world, and you added them all up, and you divided by the number of dogs, and you said the average weight is 80. And then you crunched out with that horrible huge formula or software, found the standard deviation, it was 15 pounds. What a lovely number. What the empirical rule says is 68% of the dogs of this particular breed weigh in 80 plus or minus 15 pounds. That is, 80 minus 15 is what? 70, 65? That is 65 to 95 pounds. Most of the dogs, 68%, 2/3 of the dogs are somewhere between 65 and 95 pounds. 95% of these dogs weigh in 80 plus or minus 2 times 15 pounds. That is 80 plus or minus 30 pounds. That is 50 to 110 pounds. And 99.7% weigh in what range? 80 plus or minus 3 times 15, which is 80 plus or minus 45, which is 80 minus 40 is 40, so 35 pounds to 80 plus 45, 125 pounds. And it's not so hard if you do it in this order where you start at 80, you go up 15, you go down 15, and then from that you go down another 15, and then down another 15, or up 15, up another 15, up another 15. In any case, this is the empirical rule. And it's incredibly useful. Well, this is a rough rule of thumb. We will get into more detailed analysis later, where instead of plus, we're talking about, 1 times, 2 times, 3 times, we'll be able to talk about 2.4 times or 1.7 times using a chart. But what we have here is, let's say you wanted to build a car that was comfortable for most people. There's always going to be, incredibly tall people that won't be comfortable in your car and incredibly short people that won't be comfortable in your car. But if you figure out how tall the average person is and then what the standard deviation is, if you can make it so that your car is comfortable for give or take 2 standard deviations, then 95% of your people are going to be happy. If you can make it comfortable for people within 3 standard deviations, then 99.7% of your people will be happy. This is how it works. You have the X bar, and you have the sigma. You have the mean, and you have the standard deviation. 68% is X bar plus or minus sigma. 95% is X bar plus or minus 2 sigma. And 99.7 is X bar plus or minus 3 sigma. And that should be it for today.